A challenge evolutionists use against young Earth creationism is that we don't see animals appearing within geologic strata in which we should not see them. If we were to discover organisms existing in the wrong geologic strata, then we would theoretically be able to disprove evolution. Of course, this is extremely hard to do, since evolutionists can just switch around dates, so all these taxons appear outside their previously hypothesized date range. However, there are still some taxons that make doing this a far bigger challenge for evolutionists. These are called Lazarus Taxon. Lazarus Taxon are taxa that completely disappear from the fossil record and are thought to be extinct and then appear way later again in a much later period. As we may know, Lazarus was raised from death to life by Jesus, as described in the Gospels. I kinda like it when scientists, even in their quest to destroy Christianity, name concepts after it. It's pretty neat. But now we're getting sidetracked. These Lazarus taxa appear outside of the date ranges and geologic layers that scientists expect them to. You'd think there would not be very many of these, as it would break evolution, but even the picture I'm displaying right now claims to be merely showing examples. There's even a list of over 100 more examples in the Wikimedia PDF linked in the description below. We'll discuss all of these and more shortly. We start with a Monopacophora, a supposedly ancient class of mollusks in which only one family survives today. They appeared in rocks from about 540 to 388 million years ago, but mysteriously disappeared from the fossil record for 385 million years until the Quaternary. Rather than suggesting that they lived 385 million years without a trace, it is more likely that many of them were fossilized during the flood, and that the remaining populations which survived the flood make up the Tributyid. Next up is the Xiphosaurida, horseshoe crabs. Their earliest known horseshoe crab is Lunatapsis, which lived 445 million years ago at the end of the Ordovician, which looks shockingly like horseshoe crabs today. The next horseshoe crabs appeared 35 million years later, completely bypassing the Silurian rocks. The problem is that these organisms, Maltibulacia and Wilwerathia, look nothing like horseshoe crabs, which were already in existence by that point. As such, this categorization has come under heavy scrutiny by phylogenetic analysts. The next horseshoe crab, which actually looks like a horseshoe crab this time, is the Blineridae of the late Devonian rocks, inserting a gap of at least 63 million years, if not more, between species of horseshoe crab. As before, this gap is much better explained by the flood, in which a couple horseshoe crabs were killed very early into it, rather than the horseshoe crabs just disappearing for 63 million years. Even though it was only about as long as a chihuahua, Anomalocaris was the apex predator of the Cambrian period. Radiodonta, the order including Anomalocaris, also had a large gap of 72 million years between its last two surviving species, Agirocassis, 480 million years ago, and Schinderhannes portelsi, 408 million years ago. While Agirocassis is the only known radiodont in the Ordovician, Schinderhannes portelsi completely skips the Silurian and randomly shows up in the Devonian period. It's also worth noting that Agirocassis was a filter feeder, while Schinderhannes portelsi was not, so there would be an even larger gap with its nearest common ancestor. Of course, there's also the flood that could explain how Schinderhannes portelsi was able to get away for longer than the others, but that simply can't be true, can it? Hallucigenia, a labopod, is well known for how scientists originally put it upside down and being the logo for the Cambrian explosion on Wikipedia for whatever reason. It and its labopod cousins should also be known for how they completely skipped the Ordovician and Devonian rock layers, with 55 and 100 million year gaps in their ancestry. Yikes! The next one is my personal favorite example of Lazarus taxa, Gaisonoceratidae, a family of orthocerids. Like how trilobites are the poster child of the Cambrian period, orthocerids are the poster child of the following Ordovician period. They appeared frequently enough throughout the Ordovician and Silurian, but disappeared in the mid-Devonian period. Then a genus, Gaisonocerina, which had originally appeared all the way back in the Ordovician, skipped both the Devonian and the Carboniferous to appear in the early Permian period, about 95 million years since the last Gaisonoceratidae. Then after a few 40 million years, near the end of the Permian, you have another Gaisonoceratidae appearing. And after another 146 million years, beyond the Triassic extinction event that killed all the other orthocerids, you find fossils of Zuravlevia appearing in the Cretaceous period, long after its poster child days ended. Truly an absurd case of evolution to explain. But the thing is, though, That we have species of animal that keep disappearing and reappearing again that are even more absurd than that. Acorn worms have 290 million year gaps in their fossil record and still exist today, despite their last fossils being found all the way back in the early Jurassic period. Sea spiders, also known as nightmare fuel, are the same way with 235 and 165 million year gaps in their fossil record, yet many known species whenever they appear again. Meanwhile, springtails have 120 million and 180 million year gap in their own fossil record, and these gaps aren't just because they're soft-bodied either, as 14 different species are found when it reappears in the Cretaceous. But if you need even better evidence, there's also the lamprey, an order that has a skeleton and which lives on today that has 120 and 180 million year gaps in its fossil history as well. Next we have Pachycornidae, a family of giant filter-feeding fish in which its largest member was about half as large as the largest whale and slightly smaller than a whale shark. This one's name was Elite 60s, and there would be a 62 million year gap between this and the other much smaller members of its family. If you like fishing, you may have already heard of this one, the bowfin. Yes, there's an 83 million year gap between when this family first appeared in mid-Triassic waters and when it reappeared in late Jurassic, Cretaceous, Eocene, and even waters today. Of course, it is far more likely that a bowfin just happened to get picked off early by the flood than just disappearing for a couple 83 million years. The next one is really famous. It's the coelacanth, a living fossil. They've been in the fossil record since the Devonian, 410 million years ago, but they completely disappeared from the fossil record 97 million years ago, causing us to previously believe that they had gone extinct with the dinosaurs. Then in 1938 they were discovered off the coast of South Africa, proving that they had never gone extinct and are in fact still living today. Instead of completely disappearing from the fossil record, it is more likely that many coelacanths were killed by the flood in some of the lower layers, but that others survived and live on today. Next up on the image is the ichthyosaur, and I actually had a good joke planned for this one. Unfortunately, this one is a pain to explain and not the most convincing. After that is the Chikudesauridae, our first non-fully marine animal, an amphibian. This one has a 63 million year gap between its fossils, can escaping both the mid and late Jurassic. Of course, it didn't disappear for that period of time, but some just managed to evade the flood for longer than others. Cteniogenus antiquus is a species of marine reptile with 72 million years of nothing in its fossil history between the mid-Jurassic and the late Cretaceous, and in all that time it was gone from the earth, it didn't even evolve into a new species. Yeah, right. Next is Theriosuchus, a crocodilian whose only fossilized remains date from complete opposite ends of the Cretaceous, approximately a 66 million year gap. In reality, it's more likely that some evaded the floodwaters which killed the earlier Theriosuchus, but were caught later on. At last, we have a dinosaur. Alvarezosauria lived from the late Jurassic to the end of the Cretaceous. Unfortunately for evolutionists, it seemingly stopped existing from the last Haplocharis fossil to the first Alnochetri fossil in the late Cretaceous, 63 million years later. However, this one may have a good ending for the evolutionists, as no doubt because of this gigantic gap, they've been trying to reclassify as a conjugated ornithomimosaur, leaving it with 10 and 20 million year gaps prior to other members of these groups. Therizzinosauria, you might remember one from Jurassic World Dominion or Dinosaur Train, also has a gap in its fossil record. Ishanosaurus, thought to be a therizzinosaurid from a jawbone, came about 69 million years before the next known therizzinosaurid, leaving the mid and late Jurassic bare of any therizzianosaur fossils. Besides these, Protoceratosauridae has a 40 million year gap spanning from the Jurassic to the Cretaceous, and Microraptorians have a 43 million year gap spanning across some of the Cretaceous. This one is going to really break evolution. In evolution, birds are said to have started evolving from dinosaurs around 155 million years ago, with the avialaclade being created to suit these creatures. With the evolution of Galarnus around 130 million years ago, we have the evolution of the first bird, which can correctly be called a bird. Unfortunately for evolution, there is a 45 million year gap between Galarnus and the next true bird, Austonornis. So according to the fossil record, the first bird didn't just evolve long before any others, but it also went extinct long before any others. Alternatively, and more likely, Galarnus could have just been the first bird killed by the flood. There's also quite a couple mammals with gaps in their fossil records, but nothing more groundbreaking or interesting than the prior examples. A bunch of Jurassic Cretaceous mammals disappear for 30 to 40 million years, and platypi just don't exist for a mere 28 million years. 395 million years ago, the first tetrapod, four-legged animal, walked on land. These are the same footprints being displayed right now. This is a major problem for evolution though. Abruchovitses, the first land tetrapod, only evolved 20 million years later. That means that some tetrapod walked on land before there was any tetrapods that could actually walk on land. It should also be noted that Abruchovitses and any other Ichthyostagalia were incapable of producing such footprints, as they were unable to walk in such a manner. Very unfortunate use for evolutionists. Of course, this problem is even worse regarding insects, with the first footprints dating back to the Ediacaran period 546 million years ago. This is 65 million years before when plants, fungi, and the first insects were supposed to be colonizing land, and 25 million years before the first trilobites. Absurd. I found this next one while researching an entirely different topic. All armored fish, jawless and jawed, were supposed to have gone extinct during the Devonian extinction 359 million years ago. However, one did not. Gomphatis, an otherwise Silurian jawless pterospidomorph, randomly reappeared in the late Cretaceous 400 million years later, and a whole 266 million years after any of its related organisms were supposed to have gone extinct. Truly absurd. It must be difficult to believe in evolution, with animals seemingly going extinct and then coming back again. Some of these are even in completely different layers from any other similar organisms. While not all may be as absurd as finding an ankylosaur in the Miocene, they still are destructive enough on evolution to warrant attention.